So basic functions of an SPD. So SPD has basically three major functions. In the absence of surges, SPD shall not have any significant influence on the operational characteristics of the system to which it is applied. That means once we apply SPD to a system, we install SPD inside a system. In case there is no surge when the voltage is normal and stable, SPD should not create any interference. It should be a completely passive element. It should not interfere in the normal working of a system. In this, normally in MOV based SPDs, there is a problem of leakage voltage. This can create a problem. TOV will also influence the SPD. This we are going to discuss in the next webinars. Second basic function of SPD is during the occurrence of surges, the SPD shall respond to the surges by lowering its impedance and thus diverting the surge current through it to limit the voltage to its protective level. The surges could initiate a power flow current through the SPD. That means once there is a surge, SPD should immediately respond to the surge by doing two particular things. First, it has to create a equipotential. It has to limit the voltage to its voltage protection level. Second, it has to divert the surge current to earth or source wherever it is applicable. So it will do basically two purposes. One, creating the equipotential. Second, it has to divert the surge current. Now, in case of spark-based SPDs, there can be an issue of follow current, and that can create a very dangerous situation that again we are going to discuss later. Third thing is, after the occurrence of surges, the SPD recovers to a high impedance state and extinguish any possible follow current. That means once the surges has gone, normally as I told, SPD is in NO condition, a very high impedance condition. During the event of surges, it will create a short circuit. And once the surge voltage is gone, the surge is gone, SPD should again come back to its normal state and should not create any follow current. Again, in case of spark gaps, follow current can create a dangerous situation. So additional requirements also has been specified by the standard 61643, IEC 61643, part 12 has specified some additional requirement. First one is protection of SPDs against the direct contact. That is very obvious. That means once an SPD is installed, we should not be able to directly touch the current carrying parts of the SPD. That protection we have to provide. Second one is safety in the event of SPD failure, which means once we have connected an SPD in a system, during the event where SPD comes to end of its life, that means when SPD is about to fail, there are two possibilities. First possibility is SPD can fail in an open circuit condition. In that condition, there is no problem. SPD is going to just disconnect itself from the system. Second possibility is SPD fails in a short circuit mode. Once an SPD fails in a short circuit mode, there is a short circuit current which flows from the power source through the SPD into the earth. Now, energy dissipation during the conduction of this short circuit current can be excessive and can cause a fire hazard. Hence, SPD manufacturer should ensure that their SPD should ensure the safety in the event of SPD failure. This is what is explained in the standard 61643 part 12 as well.